Hey guys, welcome back. We're going to take another look at compound interest, except this time we're going to look at something called continuously compound interest. And to do continuously compound interest, we have to learn about a new number. So there's this number called e. Now, once upon a time, you learned about this number called pi, and it was weird to learn about a number that had a name like a letter. Okay, but then you realized that it had a use and it was a non-repeating, non-terminating decimal. So rather than write out 3.14159265 blah 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 a whole bunch of times, instead they just came up with a symbol for it. Well, e is very similar. Okay, e is a number, and much like how pi is approximately 3.14, E is about 2.718 approximately. And it's once again, it's another long, non-terminating, non-repeating decimal. Now, right here is an option to watch a video about where that number comes from. There's lots of videos out there on YouTube. Now, in order to watch this video, you're going to have to go into the Notes tab or the Files tab, and you're going to have to find this one, but it'll be there for you to click on. I don't think you'll be able to click on it in the middle of this video. Anyhow, long story short, they figured out a way that they could use this number e to continuously compound interest. So last time we talked about compounding interest, and you could do that quarterly, you could do it monthly, you could do it daily. And they said, well, what if we added that interest on hourly? What if we added it on every minute? What if we added it on every second? Okay, and then they said, well, what if we just continuously added the interest onto the account? And this is the formula that they came up with. A equals P times E raised to the power RT. A real easy way to remember that is it looks kind of like a word, apert, a nonsense word, but it looks like a word. Now, what's really important, though, is what each of those variables represent. So A still represents the amount in the account time T, just like last time, same thing. P still represents the principal investment, and R still represents the interest rate. It has to be as a decimal, and T still represents the time in years. Okay, so really everything, all the variables in these equations remain the same. This is actually a slightly simpler equation to use. Okay, now, here's the catch though. We want to use this number E, and we want to be exact. And we don't want to have to type in 2.718 every time because, well, number one, that's a rounded version of the number. Number two, what if we have a typo when we type 1.781? That can actually give us a very different answer. So good news, just about every calculator out there has an option to use E. Some of them have this number right here, okay? So if you have the calculators like the ones we use in school, right here, you see this button that says ln, and above it in blue, it has e to the power of x. So if I type second and then hit that ln button, it gives me e, but I have to type in an exponent. So if I just want e itself, I do e to the power of 1, press equals, and that's about the value of e. Okay, so any formula I have with e, I want to make sure I'm using that calculator e. Okay, all right, now let's take a look at some examples here. Okay, so I invest $100 at an annual interest rate of 4.8% compounding continuously. How much will I have after 3 years? So I'm always going to write my formula first. So A equals P times E raised to the power of RT. Okay, apert. Okay, and in this story, A is going to be equal to $100. No, excuse me, that's what I'm trying to find out. So A is the amount at the end of the story, and I don't know what that is. I know that the principal investment was $100. Put that into the account. The interest rate was 4.8%. But remember, we need to write that as a decimal, so we slide the decimal point over 2 spaces, and we have 0.048. Okay, and T is the time in years. And they tell us it's going to be in that account for 3 years. So we have all of our information set up. We're going to sub that into the formula. So A is what we're looking for. That's going to be equal to 100 times E raised to the power of 0.048 times 3 years. Now, I'm sure someone out there watching this video is thinking, well, what about E? How come we didn't sub anything in place of E? Well, remember, E is a number. Okay, it's approximately 2.718. It's kind of like how we don't sub a number in place of pi. We just keep that pi character in the equation. So leave that E alone. And now I want an answer. So here we go. So now I go to the calculator and I'm going to type in exactly what I see here. So I have 100 times, get that E on the screen, raised to the power of 0.048 times 3. Now, if it automatically puts you in the superscript like this with the exponent, you're good to go. Sometimes what you'll see is something more along the lines of this. When you type that E button, sometimes you'll see E raised to, and then it opens up a set of parentheses. If it does open up that set of parentheses, okay, you type that, make sure you close those parentheses. Okay, if you don't close those parentheses, it'll probably give you a syntax error, and you'll have a whole lot of trouble figuring out what the problem is. So if there's open parentheses, make sure they get closed. Okay, now let's go back to that calculator and let's get our answer. So about $115.48.8, or excuse me, 0.488. Double check, 115.488, good. Okay, now they want to know how much will be in the account. There will be approximately, or about if you prefer, $115.49 in the account. All right, so there we go. Now let's move on to the next one. Okay, similar story. A student wants to save $8,000 for a car over the next 5 years. How much should he put into an account that pays 5.2% interest compounded continuously? Now, guys, this is the phrase we're looking for. That phrase, compounded continuously, is what tells us that we're going to have that equation APERT. Okay, and that's what makes our lives as easy as it does. So we have to make sure that we see that phrase, compounded continuously. Now, once we have it, we write the formula down and we sub in everything that we have. Now, this time, A is the amount in the account at the end of the story, and the student wants to have $8,000 when it's all said and done. So that's actually going to be our A this time. And the P, the principal, is what we're trying to find. Okay, now we still have to have an interest rate, okay, which they say is 5.2%. Okay, but we know that we have to write that as a decimal. So we slide the decimal point over 2 spaces, and we have 0.052. Okay, and T is the time in years. Okay, he wants to save $8,000 for the car over the next 5 years. So now we're going to take everything that we have, and we're going to sub it into that formula. So we'll have A, which is $8,000, equals our unknown principal investment times E raised to the power of 0.052 times 5 years. Okay, now we have everything all typed in. Okay, the only catch is we're trying to solve for P. We're trying to get it all by itself. So what I'm going to do is simplify this part, E to the 0.052 times 5. Okay, so I'll go over to the calculator and I'll type second E 0.0, hang on a second, here we go, 0.052 times 5. Okay, and that's what that value is. So I have 8,000 equals P times about 1.297. Okay, now I want to get that principal investment all by itself. So we divide both sides by 1.297. Okay, and that's going to give me, so if I do 8,000 divided by second answer, okay, that's going to divide it by the 1.29, blah, blah, blah. I'll get about 6.6. Try this one more time. 6168.412 equals the principal investment. So the student, he should, or she should, I don't think it says actually. What should he put into the account? Okay, so he should invest $6,168.42. Okay, now I know what you're thinking. How come I'm rounding that 41 up to 42 cents if that's only a 2 that comes after? But keep in mind, anytime that you're making the deposit, you should always round that up. Okay, make sure that you're saving enough money for whatever the cause is that you want. All right, so we have this new formula, guys, and the good news is it's not really all that different from the one we used in the past. In fact, it's a little bit simpler. Okay, there's a little bit less to it. The tricky part is this number E. Okay, so we need to make sure that anytime we're using that number E in a formula, first off, we need to see that phrase continuously compounded. Okay, that's what tells us we need to use APERT. Once we have that formula, or once we have that phrase, we can know to use that formula to find E on the calculator. If there's no button for E, okay, what you're looking for then is going to be ln, and I can just about guarantee that if ln is the button, E is going to be that second function. Okay. If you're looking for the amount at the end of the story, okay, that's going to be A. Sub everything on the right, solve for that. If you are given the amount at the end of the story and you're asked to find out how much they should invest, okay, how much they should start out with, you're still going to sub everything in, simplify that E part of the expression, and divide both sides by that value. And that will give you the initial deposit that that person should make. All right, guys, there's going to be an assignment posted in Teams. You can get me through email or through the chat function in Teams for any questions that you have. Please don't hesitate to ask me questions. Finally, there will be a quiz on this on Friday, just a real short little one. And again, ask me whatever questions you have through Teams or email, and I look forward to hearing from you. Take care, guys.